There are several password attacks out there, and here are a few examples of the most common ones. The first one is password guessing, and password guessing is actually one of the most common type of password attacks, but some of these techniques may be very inefficient. Threat actors can guess passwords locally or remotely using either a manual or an automated approach. Now, there are several tools that can automate the process of password guessing, and here I'm actually showing a few examples. The first one is Hydra, a tool that can be downloaded from thc.org. The second one is called TS Grinder, and the third one is called SQL Recon. And again, there are many other automated password attack tools out there. Some of them actually use a method called the brute force attack, and basically a brute force is when the attacker tries every possible combination of characters for a specific password. Another technique that they use is a password guessing attack called a dictionary attack. Since most passwords consist of whole words, either dates or numbers, these tools use a dictionary of words or even phrases, and even most commonly use passwords like QWERTY or password1 or Cisco 123, etc. As a matter of fact, there has been recent studies by security companies, and where they actually have found that the password1 is one of the most commonly used passwords out there, and especially even by administrators, which is kind of scary. Now, there are other tools like John the Ripper, Cain and Abel, that can take a hybrid approach between brute force attacks and a dictionary attack. Another password attack is password resetting attacks. And in many cases, it's actually easier to reset passwords than to use tools to guess them. There are several cracking tools out there that just attempt to reset passwords instead of actually just steal them. Now, most of password resetters contain bootable versions of Linux that can mount NTFS volumes or any other type of volumes that can help you locate and reset the administrator's password. Another technique is password cracking, and this attacks works by taking a password hash and then converting it to the original plain text. And in this case, the attacker actually needs tools such as extractors for hash guessing, rainbow tables for looking up plain text passwords, and password sniffers to actually extract authentication information. Now, the concept of a rainbow table is where the attacker actually computes all possible passwords and their hashes in a given system, and then they actually put the results in a lookup table called that, like I mentioned before, a rainbow table. Now, this allows an attacker to just get a hash from the victim and then just search for that hash in the rainbow table to get the plain text password. Now, to mitigate a rainbow table attack, you can disable LM hashes and use long and complex passwords. Right, so the longer and the more complex the password is, the harder it is actually to enumerate passwords in a rainbow table and use a rainbow table attack. Now, another technique is password sniffing, and the threat actor just sniffs authentication packets between a client and a server and extracts, the password hashes or enough authentication information to begin the cracking process. Now, the last one is password capturing, and this typically is done using keyloggers, whether it's physical or software keyloggers or Trojan horses as well. There are many wireless specific attacks. Here we will cover some of the most common ones and the most popular ones. So the first type of attack is when an attacker installs a rogue access point and can create a backdoor, specifically if one is not conversant with it and have complete management of it, right? So after this rogue access point is installed, the attacker can then scan and launch other attacks within the corporate network, right? Another attack is the jamming, actually the wireless signal, to actually cause interference. And the purpose of this attack is actually to cause a full or a partial denial of service condition in the wireless network. Now, another popular attack is the evil twin attack, or an attack called the evil twin. And this is done when the attacker is trying to create a rogue access point to gain access to the network or steal information. And basically what they do is actually just purchase a wireless access point or a wireless router and then plug them into the network. Then, they configure them as exactly as the one that exists in the corporate network. And that's done so that your client connects to the access point, and then they can actually steal your information. As a matter of fact, there are actually many tools and devices that allow you to do this type of attack. A simple one is a multi-use wireless exploitation tool, or also hardware, called the Pineapple. That's actually made by a company called Hack5, or an organization called Hack5, and it's very popular among a lot of penetration testing individuals, and of course, attackers as well. You can also use other tools like Airmon and Aircrack to actually perform all these type of attacks, and there are many more out there. As a matter of fact, Airmon and Aircrack are part of the Kali Linux distribution, and basically Kali Linux is a framework. It's basically a Linux distribution that has tons of penetration testing tools and tons of attack tools all into one environment. Another attacker is bluejacking, and this is when the attacker sends unsolicited messages to another device via Bluetooth, right? So this can actually be done to attack any Bluetooth-enabled device. Another one is the initialization vector attack, and that's when the attacker can cause some modifications to the IV, or initialization vector, of a wireless packet that is actually encrypted during transmission. And basically the goal of the attacker is to obtain as much as information about the plain text of a single packet and generate another encryption key that then can be used to decrypt other packets with the same initialization vector. Now, we also have protocols and implementations that are full of different vulnerabilities. A perfect example is WEP. So the WEP protocol is susceptible to different vulnerabilities, as well as several versions of WPAs. And these protocols, again, are susceptible to vulnerabilities and are considered weak. Right, so there are many attacks against WEPs and many versions of WPA. So you should avoid using WEP and those versions of WPA whenever possible. Now, another wireless feature that is susceptible to attacks is the Wi-Fi Protected Setup, or WPS. And in this screen, I'm actually showing a link to a document from the Wi-Fi Alliance that explains what is actually WPS and how it works, in case that, of course, you're not familiar with that feature or that implementation. Now, most of the attacks that affect WPS are password guessing and brute force attacks, right? So they're aimed to obtain the WPS passwords and then use those to gain access to the network and, of course, its data. There are many types of evasion techniques used by attackers nowadays that they use to avoid being detected by security technologies and security products, right? Here I'm actually going to cover some of the most popular ones. So starting, the first one is the use of encryption. And there are many use cases where an attacker will actually breach a network and then launch some type of form of VPN session, right, to encrypt the data, or encrypt the data that is actually stealing, right, not only in transit but also at rest, right, so that will avoid being inspected or detected by any security device like IPS or other types of data loss prevention systems and so on. They also use encryption to communicate, for encrypting the communication from a compromised system to a command and control system, so that he or she can actually use that connection to manipulate and send instructions to actually that compromised system, right? Another type of evasion techniques is the use of resource exhaustion attacks, right? So denial of service attacks that can be used to evade detections and simply distract, of course, the administrator and then, of course, launch a more sophisticated attack to, potentially steal data and exfiltrate information, right? A simple definition of a resource exhaustion is actually consuming the resources necessary to perform an action. And in some cases, actually, it can be launched against a security technology or a security product like an IPS device, right? So if you can actually consume, the resources from that device, perhaps, you can launch a successful attack, other than just a denial service attack, of course. Now, another evasion technique is traffic fragmentation, right? So network technologies expect traffic to move in a certain way, known as the TCP/IP suite, right? So understanding how this works can help identify when something is actually operating in an unusual behavior, right? So fragmenting traffic is actually a method to avoid detection by breaking up a single internet protocol or IP datagram into multiple smaller, size packets. And the actual goal is to abuse the fragmentation protocol within IP. And then, creating a situation where the attacker's intended traffic is actually ignored, right? Or led through as trusted traffic by a firewall or an IPS device, right? Or any other security product, right? So the good news is actually that most modern intrusion detection and intrusion prevention systems are aware of this type of attacks and actually can prevent it fairly easily, right? So IPS products should be able to actually, to properly reassemble packets to evaluate them and to see if actually they're malicious or not, right? So this actually includes understanding the proper order of these packets, right? Unfortunately, attackers actually have various techniques that they can actually use to confuse an IPS solutions during the reassembly process, right? An example of this is actually using a TCP segmentation and reordering attack designed to confuse the actual detection tool, and they do that by actually sending traffic in an uninspected method, which actually hopes that it can properly reassemble the traffic and identify being as malicious in some cases, right? Security devices that cannot perform traffic reassembly will automatically fail to prevent this type of attacks, right? So some security devices actually will fail when the attacker reorders or fragments the traffic with enough tweaks in order to accomplish, this bypass. Now, another type of evasion techniques is a protocol level misinterpretation, right? So a protocol, as you know, is a set of rules or data structures that actually governs how computers or the network devices actually exchange information over a network, right? So a protocol actually can be manipulated to confuse security devices from properly evaluating traffic. And this is done because many devices and applications expect network communications to follow the industry-defined rules when the protocol is actually used. So the key understanding on how the protocols should work and attempting to see if the developer of the receiving system, define defenses, such as, limitations to what is actually accepted, a method to actually validate what is actually received, and, many others, right? Now, the second key piece is actually identifying what happens when a receiving system encounters, something that doesn't understand, seeing, right, or inspecting, right? And that, of course, can cause a failure, and failures, will cause traffic to be ignored or be dropped or delayed, right? So, which can all be used to an attacker's advantage to then, of course, evade being detected, and also, allow for him or she, to actually steal information from the corporate network. Another type of attack that is used for evasion is timing attacks, right? So in cryptography, actually, a timing attack is a side channel attack, which, the attacker actually attempts to compromise a crypto system. And it does that by analyzing the time that it actually taken to execute the cryptographic algorithms, right? And they're very opportunistic attacks, right? So every logical operation in a computer, takes actually time to execute, and the time can actually be different based on the the input and different type of measurements, right, or different type of environmental factors, right. So if an attacker actually can work backwards to the input and predict and be able to actually do, again, just like the word says, very timely measures, it actually can cause an evasion in a lot of situations, right? So how much just such information actually can help attackers depend on how many on the many variables that actually are present, right? So that includes the crypto system design, the CPU actually running the system, algorithms used, assorted implementation details, the other type of countermeasures that may be in place. Also the accuracy of the timing measurements and so on, right? So timing attacks are actually often overlooked in the design phase because they are so dependent on the actual implementation, right? So again, timing attacks are yet another form of evasion techniques actually used by attackers, to avoid being detected.
Operations center in the SOC always have to try to have complete visibility into what's happening in the network. However, that task is easier said than done. There are a lot of different challenges that can lead into false negatives. So in other words, where you cannot detect malicious or abnormal activity in the network. And here I'm going to go over and highlight some of these challenges that you will indeed face in the Security Operations Center. The first one, by far, is encryption. Encryption has a lot of benefits for security, a lot of benefits for privacy, but in the world of incident response and forensics, it can present a lot of different challenges. Even law enforcement agencies have been fascinated with the dual nature use of encryption. Whenever you protect information and communications, definitely encryption has numerous benefits. However, the same mechanisms can be used by threat actors as a method of evasion and obfuscation. Now, many security products, including next-generation IPS and next-generation firewalls, can intercept, decrypt, and inspect, and then re-encrypt the traffic, even ignore the encrypted traffic payloads in some cases, right? However, some people may consider this a man-in-the-middle attack, and specifically nowadays, with a lot of privacy concerns, a lot of companies are actually trying to divorce from that, especially because of regulation, right? Think about GDPR, for example. Now, you can still use metadata from network traffic and other different security event sources to investigate and solve security issues. Now, you can obtain a lot of good information by leveraging things like NetFlow, firewall logs, web proxy logs, user authentication information, and even passive DNS data. Now, Cisco has a technology called Encrypted Traffic Analytics, which basically is integrated into StealthWatch and Cognitive Security, which will help you determine if some type of communication may be malicious by examining that network metadata, including NetFlow and logs from servers, logs from firewalls, and so on, to be able to determine that, right? And it also uses behind the scenes something that we call cognitive security. Another challenge that you may encounter in the security operations world, right, is whenever you're inspecting traffic that may be, coming after a device is actually performing network address translation, or NAT. And specifically, also whenever you're doing port address translation, in other words, PAT, right? NAT can present a challenge whenever you're performing security monitoring and analyzing logs and, many other things like even NetFlow that we just mentioned, because what you're seeing in the log is the translated IP address versus the real IP address that each of the systems has, right? So in the case of port address translation, or PAT, this could become even more problematic because many different hosts behind that device, behind that network infrastructure device, whether it's a firewall or a router, a switch, and so on, can be translated to a single address, making the correlation a lot basically impossible to achieve, right? Now, some security products, like the Cisco StealthWatch system, it provides features that can be used to correlate and map, quote-unquote map, that translated IP address with things like NetFlow. This feature in the StealthWatch system is called NAT stitching. And basically, this accelerates the incident response task and eases the continuous security monitoring operations within your environment. Another big challenge in a security operations center and basically in your security operations as a whole is whenever different systems are not using the correct time. And that's why it's extremely important for you to use the network time protocol to ensure that the correct time is actually set in all the devices within the network and they are synchronized. That's because it actually will help you, of course, correlate the information. Imagine if you have a log saying that it's 2 o'clock in the morning and, something malicious was happening, and the next device that you're trying to correlate the information from, it says that no, it's 3 o'clock in the morning. So it makes it extremely hard, if not impossible, for you to be able to correlate and protect your network. Now, another best practice, kind of related, right, is try to reduce the number of duplicate logs. That's why you have to think and plan ahead and as to where exactly you want to deploy things like NetFlow and how will you correlate it with other events like syslog from other devices and so on. Now, for many years, threat actors have been using many different non-traditional techniques to steal data from corporate networks. That includes things like DNS tunneling, right? As you probably know, DNS is a protocol that enables systems to, of course, to resolve domain names. For example, if you want to resolve hacker.org, cisco.com, etc., that's how you translate it or you resolve it to an IP address. Now, DNS is not intended for a command channel or even tunneling for that matter. However, attackers have developed software that enable tunneling over DNS. And as a matter of fact, you can also tunnel data and tunnel traffic over other protocols, like, for example, NTP, the protocol that we were just talking about as a best practice, the network time protocol, also have been used for exfiltration. And there are many different other ones that also have been used. And specifically, since attackers know that probably these protocols are not going to be blocked within the organization, it allows them to either encode sensitive data, like, for example, put base64 encoding and then putting that type of data, with whether it's a stolen credit card, personal identifiable information, many different types of data in the payload of the DNS packet, right? And that then subsequently it's exfiltrated outside of the organization. And nowadays, just like we were mentioning in the beginning of this lesson, encryption is being used very, very heavily. So if you actually have an encrypted payload inside of the DNS packet that you cannot inspect, then of course that's a recipe to disaster, because an attacker can then, of course, embed any type of sensitive data that is actually able to, or trying to steal and successfully exfiltrate it from the corporation. So these are some of the most common different types of evasion techniques and challenges of the Security Operations Center.